Yo, 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 let's get rolling with solving equations part 1. Question to think about. How can we solve equations for an unknown variable? And there's a lot of strategies that go into it. First, let's go over something that's very important on this topic, inverse operations. These are opposite operations that undo each other. For example, plus and minus, they're opposites, they cancel each other out. Multiply, divide, these are opposites, they cancel each other out. That's important. Next, isolate the variable. This word isolate means to get alone. So this isolate the variable, get the variable by itself on one side of the equation, the equal sign. Once you do that, you know what the solution is. You've solved it. Here we're going to talk about balanced moves, making sure we keep equations equal. Whatever you do to one side of an equation, you must also do to the other side of the equation. In other words, you must keep the equation equal or balanced. Let's take a look at this equation here. 2 plus 3 equals 5. That's a true equation. 2 plus 3 equals 5. Let's see what happens when we add 1 to both sides of the equation. If I say, all right, let's add 1 to the left of the equal side, add 1 to the right, that would become 1 plus 2 plus 3, which equals 5 plus 1, which is 6. That is true. This is balanced. Perfect, balanced. And you can write that in your notes as well. That's balanced. Over here, if we only add 1 to one side of the equation, 2 plus 3 equals 5, let's just add it to the left side of the equation. That's going to give us 1 plus 2 plus 3 equals 5. This is not balanced. So we have to keep balance to both sides of the equation. When you are solving for a variable, you must use inverse operations to isolate the variable on one side of the equation. You have to use these inverses to get the variable by itself. Let's take a look at these one-step equations. For one-step equation, you use one. That's why they're called one-step. One inverse operation to isolate the variable and get the solution. Practice these balanced moves. Some of these you might be able to solve in your head, but don't just solve them in the head. You're going to need these skills once you do more difficult problems. That's why it's important to show your work. Let's do a few of these examples. X plus 4 equals 8. Well, we have this plus 4 that we have keeping the x from being isolated. So we do the opposite of that, and we minus 4 from both sides of the equation. So we minus 4 here, minus 4 over here as well. That cancels out our 4, leaving us with just x equals, and then 8 minus 4 is 4, which we can check that back and it works. 4 plus 4 is 8. We've isolated the variable by subtracting 4 from both sides. Looking at the second example, we have a minus 2 equals 1. The opposite of minus 2, inverse operation, is plus 2. So we do plus 2 to both sides of the equation, and that's going to give us the 2's cancel out, and a isolated equals 1 plus 2, which is 3. Next, we have 3y equals negative 9. When they're next to each other like this, that's multiplication. So the opposite, the inverse operation of multiplication, is division. So we divide 3 on both sides, divide 3, and negative 9 divided by 3 is going to give us y equals negative 3. This 3y, 3 divided by 3 is 1, so we just have the y left, and negative 9 divided by 3 is negative 3. Sorry. Lastly, z over 2, z divided by 2, a fraction's like division, equals 5. The opposite of division is multiplication, so we're going to times 2, multiply 2 both sides of the equation, always both sides. That times 2 is going to cancel out with the divided by 2. They're opposites, leaving z isolated. And 5 times 2 is 10. So we get z equals 10. Use these examples right up here and see if you can figure these solutions out by using inverse operations. Use the same steps, but just with these different numbers. Try that now. All right, let's take a look at this first one here. X plus 1 equals 7. We have x plus 1. That's what we want to get rid of to get the variable by itself. So let's minus 1 from each side of the equal sign. That's going to cancel out our 1's here, leaving us with this x. And then we have 7 minus 1. 7 minus 1 right there, and that equals 6. So that's our solution, x equals 6. For the second one, we've got a minus 5 equals negative 10. To get rid of that, inverse operation is going to be plus 5. Make sure I do each side of the equal sign. There's my little equals line, both sides of the equal sign. That's going to cancel out my 5's, leaving us with a equals negative 10 plus 5. And negative 10 plus 5 is going to give us a negative 5 answer. And that's going to be our solution there. Moving on, we've got negative 2y equals negative 20. Since it's a coefficient, it's right next to it. The opposite is going to be division. So I'm going to divide by negative 2. Also divide by negative 2 on the right side of the equation. These 2's are going to cancel each other out, leaving me with y equals negative 20 divided by negative 2, which is going to be a positive 10. Lastly, z divided by 7. Opposite of division is multiplication, so I'm going to times 7 on the left, times 7 on the right. Again, both sides of my equal sign. You could also use a dot so you don't get confused with variables. Dots work as well too. This divided by 7 and times 7 will cancel, and then we'll have negative 7 times 7 to get negative 49. And all of these solutions can be checked if we put them back into the original equation. We can see that those work. And that's what it says right here. If you want to check your solution, put it back in the equation, see if it's true. Onward and upward, two-step equations. Use, can you guess it? Two inverse operations to isolate the variable. Same process, there's just two things going on instead of one. First, start away from the variable. Use addition and subtraction. Next, isolate the variable. Use multiplication and division to get that variable finally by itself. We're going to walk through a couple examples over here. First, we've got negative 8b plus 12 equals negative 28. We want to get rid of this plus 12 first. Use the inverse operation of addition for the plus 12 and subtract, because those are opposites, 12 from both sides of the equation. So we'll do a minus 12 here and a minus 12 here. Doing that, these 12's will cancel. We'll get negative 8b equals negative 28 minus 12 is negative 40. Now it's like a one step, but we have negative 8 times b. So let's use the inverse operation of multiplication of that negative 8 and divide negative 8 from both sides. If we do that, we'll have divided by negative 8, divided by negative 8. These negative 8's will cancel. Times and divide, those will cancel each other out. And negative 40 divided by negative 8 gives us a final answer of b equals 5. And b is 5. We get that right there. If we wanted to, again, we can plug that in. So we got rid of the 12 first, then got rid of the negative 8 by dividing. Let's do one more. Here we've got m divided by 4 minus 6 equals negative 10. Let's start by using our addition or subtraction, get rid of this minus 6. So we'll use the inverse operation of subtraction and add 6 to both sides of the equations. Instead of minus 6 here, we're going to plus 6, both sides of the equations. Those 6's are going to cancel out, and we'll have m divided by 4 equals negative 10 plus 6, which is negative 4. Now we need to clear this 4 out, which is division. So we'll use the inverse operation of division and multiply both sides by 4. If I do times 4 here, times 4 on the right, these 4's will cancel out. Divide 4 and times 4 cancel. And we're left with our m equals negative 4 times 4, which is negative 16. And that's what our m is right there. Follow the steps from these two examples and try, see if you could figure these two out on your own. Remember, start with the number away from the variable. So start getting rid of the 6, then get rid of the minus 4. Start by getting rid of the 9, the minus 9, then get rid of the 2. Try those now. Let's see how you did. Starting on number 1, negative 4b plus 6, we want to get rid of that plus 6 first. So we will minus 6 from both sides of the equation. Those 6's will cancel, leaving us with negative 4b equals negative 10 minus 6 is going to be negative 16. Now to get rid of this negative 4, to get the variable by itself, that's negative 4 times b. So let's divide by negative 4. And one way we could do division is if we just put a fraction line. Divide by negative 4, divide by negative 4. If you wrote the division sign, that's great too. Those will cancel each other out, and we'll get b equals negative 16 divided by negative 4, which is going to be a positive 4, since they're both negatives. Number 2, m over 2 minus 9 equals 7. Let's start away from the variable using the inverse operation for minus 9. So plus 9 on the left, plus 9 on the right. Those will cancel out those 9's, leaving us with m over 2 equals 7 plus 9, which is going to be 16. Now we have this m divided by 2. To get rid of the divided by 2, we want to do the inverse operation times 2. And I'm just going to do this dot 2 to show my times. So 2 divided by 2, 2 times and divided, those will cancel each other out. We're going to get m equals 16 times 2, which is going to be 32. And we have our solution. And if we check those, if I put 4 in for here, negative 4 times 4 plus 6, that'll work out. And if I test this, 32 as well. I hope that made some sense. We'll be doing lots more practice with solving equations. Go and take some time to write your 3 to 5 sentence summary about what you've learned. Answer those questions at the top, and I'll see you next time.